Good evening, students. Today we are going to start our new chapter of mathematics, the surface area and volume. So in this chapter, we have to learn about the three-dimensional object. Three-dimensional objects are non-planar figure, though they are drawn on two dimensions for understanding only. So these three-dimensional objects are always enclosing certain volume. So in this chapter, we are always asked for calculating the area of the object. This area can be the sidewise area or lateral area or curved area of the object, or maybe the total area or total surface area. Total surface area includes the bottom and top in addition to their lateral surface area. Then how much volume is bounded by this total surface area, that we can also calculate. So we always have to calculate the surface area, maybe the lateral surface area or curved surface area, or the total surface area and volume. Like in our previous chapter where we have learned the plane figure. For the plane figure, we can have the boundary length called perimeter and the area enclosed on the same plane, means the area. So these two things, perimeter or boundary length and area, is calculated for 2D figure. 2D figure are the planar figure. They do not have any projection in third dimension or in the space. But for the three-dimensional object, it always have length, width and height also. So for this 2D, we can have length and breadth only, or if the circle is there, then the radius only, it were enough. But for the 3D, it have the length, breadth and the height also. Even like the circle have to be placed one over the another so that the height will raise and it form a cylinder. So even if the radius is there, still it need to give certain height. Now the height or the circular area or circular ring need not be the uniform. It may be maybe decreasing or increasing depending on that. If it is going to meet at one point or forming a single vertex, or the single point, it is forming a cone. So at the time when the cone is there, we can have the radius, the height h, and this length is called the salient length L. So it could be the radius, height or salient length. It may be possible that this cone is now cut by another plane so that it is able to form something like this, or the three-dimensional object like your the drinking glass. They are of this shape, though they are inverted. Lower one is of the smaller circular area and the open one is of the bigger circular area. So here we have the two radius, r1, r2, and this is the height h, and this is called the salient length L. So it can have r1, r2, the height h and the length L. So this structure is called as the frustum. So these are the things that we want to learn in this chapter. A student, the very basic three-dimensional shape is our cube, cuboid, cylinder, a sphere, cone. And regarding this, the formula we have already learned in our class 9. Though I will rewrite it, but I will not derive it. I will just collect all those formula. Now these parts maybe get connected to form a new shape. So in this standard in class 10th, we have to learn about the connected three-dimensional object, because in class 9th we have learned about the basic three-dimensional object. Now 2 or 3 of these three-dimensional objects are get connected, then how to calculate? So right, connected 3D object or combination of objects or three-dimensional objects. So whatever the technique we have learned last day, everything is equally applicable here. But we have to take care, in place of the perimeter or boundary, we need to calculate their surface area, and in place of the area for the planar figure, we need to calculate the volume by applying the formula that I am going to write. Another important thing, again here we need to divide the entire segment into the known shapes. So these objects or shapes may be. Example, let us consider a cylinder is there. Let me take a cylinder. So we can take a cylinder. There are some provision of these shapes also. Where is that? No, this is the color picker. Yeah, it is here. If we consider this as the cylinder, now this is the basic structure or basic thing, where the cylinder is represented by its radius, its height, radius from the center. A student, even the bottom one is also circular, the other part is hidden, so it is not shown. The center is there, so the radius is also here, and the height between these two center, it is called the height of cylinder. It is the height h. Or the same one is for the curved surface or height of the curved surface, because we are considering the right circular cylinder, it is like this one. So the same height is even this one also. Okay? It is the cylinder, the basic structure. We will learn about this, what is the volume, what is the surface area, all these things. Now it is possible to put another sphere over this. Then while taking the sphere, let me take a sphere over this, no provision of a sphere. No, a sphere cannot be drawn. Can I rotate it? Difficult to draw. Let me draw by the finger itself. We may consider it like this. See, this is the representation of a sphere. Or basically, what is this sphere? Means the entire this area, even this curve is indicating that it is being covered. Means this entire this one is covered by another hemispherical end. Then how to get the total surface area? For that, again we have to divide it into the two parts, one as the hemisphere and another one as the cylinder. Then we have to apply the formula for this sphere or hemisphere and cylinder. The other end may be made the conical. It may be possible to connect it by a cone. Then you are asked to calculate the total volume occupied by this object and the surface area. What to do? Again, you have to divide it into the basic known shapes of one part is our cone, another from here to here is our cylinder, and this top one is our sphere. It is basically the hemisphere, means half of the sphere. So whatever is the hidden, means the joint, that is not considered, like the surface area common to the circular area of the cone and the circular area of the cylinder need not be considered. So for calculating the lateral surface area or curved surface area, we need to consider the curved surface area of this cone, this cylinder, and this hemisphere. And for calculating the volume of these three have to be added. So this is how to get the area and volume of connected figure. So for this connected figure, you need to find the area is equals to what, volume is equals to what. So the steps I am not going to write. I had already explained for the 2D figure the same thing, but I will apply. So that's why it is important here to recall all the formula relating the basic shapes like our cube, cuboid, sphere, cylinder. All those things are very important. So I am going to write the formula for the surface area and volume of the basic shapes. So write basic formula. So you write it in the table form. So whatever the object or shape that we are going to consider, that we will take. Very first, we will take the shape. What is the shape that we will write? Then after this shape, means in this shape we will also draw the figure and write there some of the important feature. Then we will write their lateral surface area. I had just explained lateral surface area or curved surface area. Then we will also write here the total surface area. These two things in this column we will write. Then we will write the volume occupied. Volume. These are the three things that we are going to write for each of the shape. And by connecting these basic shapes and basic formula, we can get the surface area and volume of the connected object or connected shape. So student, recall your very basic shape. It was our cube and cuboid. It was starting with that one. So let us consider the cuboid first. Everyone is knowing since class 9th that if we are taking a rectangle like this and this rectangle have the length and breadth, now if you place one rectangle over the another, it will gain some height and it form a shape called cuboid. Like your notebook or your book, one of the sheet is acting as a rectangle, but placing one seat over the another and large number of seats, say 100 or 200, it gains some thickness. At that time, it have volume, and the new shape is called as cuboidal shape. So for representing this length and breadth, these two have to be projected upward. So project it upward. Upward projection is shown here with the slanted line. So this is the height h it have gained. We can draw like this. And the one portion that is being hidden is this one. So it is this. The basic feature and characteristic you are learning since class 6. I'm not going to write all those things, but some of the things that we can write here. How many diagonals are there? We are talking for the diagonal of cube or cuboid. At that time, we shall take the vertically opposite. I mean, the vertex which are at maximum distance, not for a particular surface, but for this entire cuboid. Means if you are taking the vertex, say this one, which is representing one of the corner, then here with this vertex you are getting that this is the one surface which is formed. There are three other vertex. You need not take these three other vertex. Rather than you shall go for the opposite surface to this one. What is the opposite surface, student? So go for the opposite surface first. First allocate that opposite surface. Your opposite surface is like this one. Observe carefully. Sorry. The opposite surface is like this one. It is this one. Are you getting? It is this one. Now, keep in mind, if you are considering this vertex, it is not at the maximum distance. So in this case, you are observing that the opposite surface with this vertex, it is at the maximum distance. So joining these two vertex which are at the maximum distance, it gives the diagonal. So in this case, the diagonal is represented like this. It is the representation of diagonal. It is one of the diagonal. The other diagonal you may take. How many diagonal can be drawn? It is one of the diagonal. You can start with the other one also. You can start with, say, this surface, or let me draw another color. You may start with, sorry, this vertex. Then again you have to go for the opposite one, and in that the maximum one, it could be this one. In figure it appears as one bigger, another smaller, but all are equal. This you can analyze. The room in which you are sitting, that is also of the cuboidal shape mostly. If you consider one of the corner and just the corner in front of you, but at the maximum height, that will give you one of the diagonal. Say in my left, at the bottom, one corner is there. That, and in my front, on right, I have to go for the other corner of the ceiling. So this from left, bottom to right, top, that will give one diagonal. Another, I may take from left, top to right, bottom. That will give me another diagonal. Is there any other one? Yes, for the other one. From the right, bottom to the left, top. That will give the third diagonal. The other from my right top to the left bottom in my front. So these way total 4 diagonals are there, and all these 4 diagonals are equal in length, and this diagonal length can be calculated. So right, student, it is this one I have shown. Even the one is what the else is there, you can also draw like this. It is this one, then it will be this one, it will be this one that you can get. The other one is this one, and then this one you are getting opposite, it is this one. So these are the 4 diagonals. So here 4 diagonals, and this diagonal length or 4 equal diagonals, they are of the equal length, means all these 4 are equal, are equal. So if we denote this diagonal by D, then D is obtained by applying the Pythagoras theorem. So D square is equals to L square plus B square plus H square. This you have to keep in mind. The question or MCQ is even framed from here itself. Okay. So that's why I am rewriting, though these things are belonging to your class 9 and previous standard, but it is us. So it is one thing. How many surface area or planar surface? So you can understand like this. Consider this shape: 1, 2, 3, 4, and one top, another bottom. So 6 rectangular area. Okay. If I consider one as the bottom and placing it downward, the another as the ceiling. So just leave this. Always consider the length and breadth for the bottom one and the top one. This is the height, the projection we are showing. So in this 6 rectangle, 2, one is the bottom, another is the top, plus 4 is there. In the 6 we have to understand like this. So this top and bottom, top is what? The orientation in which the object can be placed. Say it may be possible that this is the object. Consider this. This is the object. Are you getting? It is the object. It is the object, or it is the object. If you are placing it like this one, say like this one, at this time, this itself is acting as the bottom, and this is acting at the top. This is the side one, another side one, another side one, another side. Are you getting? So these bottom and top are not fixed, but rather it depends on their orientation. So carefully you have to calculate if the cube or cuboid is given. Okay. So the other 4, these are forming the lateral or curved part. With this 6 rectangular area, the volume is bounded. So this volume and this lateral surface area, means with the 4 sidewise rectangular surface area, we can calculate the curved surface area or lateral surface area. A student, this curved surface area and lateral surface area mean the same, but these terms are used depending on the shape. Say if you are considering the cylinder, their side area are curved, so most commonly we are using the curved surface area. For the cone, we are using the curved surface area, and for the rectangle or say rectangular side surface like cube and cuboid, we are using the lateral. Okay, but both mean the same thing. Adding this lateral surface area with the surface area of the bottom and top, we can get the total surface area. So it also have some surface area of the top, surface area of the bottom. So if you are adding all these 6, you will get the total surface area. So we may write like this. This is the explanation. I will write everything in the same manner for the other figure. There I will not explain, rather I will write. So understand the explanation for only one figure carefully. So the total surface area is obtained by lateral surface area plus surface area of top plus surface area of bottom. These are the things that we have to do. If it is a cylinder, then top surface area, bottom surface area, they are always equal, so that doesn't make any difference. But if we have the cone or any other kind, say frustum, at that time the top surface and bottom surface are different. If we have the hemisphere, there is only bottom surface, no top surface area. So this is the formula or relation between lateral surface area and total surface area. A student, this is TSA and it is STA, means surface area of top. So we can write in complete or in more detail, total surface area is equals to lateral surface area plus surface area of top plus surface area of bottom. Is it okay? This is the relation. For getting the volume, a student, if we have the base, their surface area is known, multiply it by height, the volume gets generated. Getting? So volume is obtained for the uniform figure only, not for the all kind of figure. Like for the cone and frustum, we cannot apply this. So volume is obtained by considering the base area multiplied by height. This we have learned in class 9th also. So this is applicable for uniform body like cylinder, cube, cuboid, all these things. It cannot be applied for the non-uniform height or the surface area, like for the cone and frustum, a sphere, we cannot apply this. So from uniform height, if the height is varying or the side is varying, that is, it is for cuboid, cube and cylinder, only these three. It is not for, you must write, not for cone, frustum and a sphere. This relation is not applicable. Then there is a specific relation that we can get. How is this? We will write for the cylinder, cube, cuboid, and we will get it. So these are the basic things that we must understand. After this, this much analysis or everything is applicable for all kind of figure. But what is the specific formula for that? For the cuboid, we are interested. So in this cuboid, we are getting that if the rectangular side length and width is projected up to certain height h, we can get it. So for this, the surface area can be obtained by adding the surface area of each of the rectangle. Therefore, the lateral surface area is obtained by adding the surface or rectangular surface area for the side walls only, not for the top and bottom. So lateral surface area, for this keep in mind, this is the base that we have considered. This base we need to leave it, rather one of the side based on this length and height is formed, their area we need to take. So how much is this area which is unshaded here? This can be obtained by L into H. Another, with this one, this side B and the same height H, this area will be your B into H. Now the same is also true for the other one. What is that? That one is the hidden. This rectangle which is formed here, it is also the height H and form over the base B only. This is the base B and this is the height H, and this angle is a student 90 degree. Though we are drawing on this plane of paper, therefore we have drawn it in the slanted form, but these angle are always 90 degree. All these three lines LB and H are perpendicular. So this surface area is obtained by B into H. And what left is the last one more is there. It is our this one. This is also our L into H. So these are the four surface area that we are getting if the ceiling and bottom are not considered. So considering these four, we can get the lateral surface area. So lateral surface area is obtained by adding L with H, but this L with H is also on the opposite side, so symmetry we can use. So even we can write it directly, 2 here and B with H. This is also occurring 2 times, you are getting on the opposite side, so 2 here. Here the 2 H can be taken common, so L plus B. So this is the LSA for a cuboid. This we have to keep in mind. Even no need to mug up this formula, just by your understanding you can write it very easily. Understanding is very important. So how I have arrived to this formula? Just by observing the rectangular surface area or combining the rectangular surface area. Now if we are considering the TSA, so this is our LSA. In this, the surface area of top we need to consider and surface area of bottom we need to consider. So it was our twice LH plus twice BH. I have substituted in this form. What is our for the top? What is left for the top and bottom? Say for the shaded area or the black hatched area, it is obtained by multiplying this L with the B. So it is LB. Similarly for the top one, the length and width are the same, so also the area will be LB. So surface area of top is LB plus LB. So 2 of LH plus twice of BH plus twice of LB. Or a student, you can keep in mind how to remember this. 2 is always there. Now we have L, B and H. These are the 3 dimensions available. We have to choose the possible pairs with these 3. I can choose LB and LH. Then starting with B. For B, what we can write? We can write B with this H and B with this L. Again with this H with B H with L. That way, by adding all these things, you can get, or directly you may write, first you write, choose the two, L and B. Okay, after this length and width for the base, you take the height, plus with this L you take one of the H, and the other left one is the base B. With that B you also need to take the H. You will get the same thing. So how do you feel convenient? You have to keep this thing in mind. It is important that you write this formula directly. Do not waste the time in thinking. That's why the practice is important. So this TSA is obtained very easily just by simple imagination and simple manipulation of this LSA. So it was our TSA. So this is the other formula that we have to keep in mind. Now coming to the volume, how the volume is generated? A student, this volume is generated by taking a rectangle. So rectangle have the length L, width B, and this is going to raise to certain height H. Means the same thing is being repeated. Means this L and B have to multiply with this height H. So the volume can be obtained by base area. Base area is L into B, like I have written here also. The base area multiplied by height. Since the same base area is being projected upward, means there is no any change in this area in different layers. So that's why this can be simply multiplied with height H. So volume is LBH. It is this. So it's so simple kind of thing you have to keep in mind. So this was about our cuboid. Once we have understood the concept, remaining things are very easy. Now let us come for the cube. How to go for the cube? Student, the second one is our cube. How is the figure? All the 6 surfaces are equal. Means the squares are placed one over another, so that a three-dimensional object is formed. It is like this. This dotted one is showing that it is inward, and you are looking from one of the corner. Means you are looking from this end. Are you getting? So while you are looking from this end, and this is in slightly tilted form, you are observing that you are able to see this side, and this side. The other vertex is hidden, and the other 3 sides are also hidden. What they are? One is this one, and this one. These were the hidden. So that's why we are always projecting like this. So it is that kind of projection. In this case, all the length width are equal, and it is denoted by A itself. This is the height. H is also A. Means even this way you can understand the hidden one, or placing this on the plane of paper, you have placed with this as the length and this as the width, and this is above. Means the plane of paper is like this. Consider this is the plane of paper, and here you have just placed it. At that time the bottom one will be not visible to you. Directly the height will be visible to you. So you can understand this way it is equally convenient. So denote at one as length and breadth in the form of parallelogram, and project the height as a perpendicular line. This is the way. Or draw the square and project the height with the slanted line. So in this case, again, the diagonal D can be obtained by What is a square plus a square plus a square? So it is like a root 3. It's so simple. So diagonal relation is this one. The TSA twice L, sorry, twice of H, L plus B. This was the formula for cuboid. This is A, this is A, this is A. So this become like twice of A plus A. This is like twice of A into the inner one is also twice of A, 2 to the 4 of A square. Or you may simply consider 4 A square sides are bounding this. Therefore, the LSA is our 4A. But for TSA, 2 more are getting added, so it becomes 6A square. It's very easy. Are we getting? So no need to mug up, just by observing you can write. Now coming to the volume, the base area into the height. The base area is A square, A into A. The height is also A, so volume is A cube. Where what we are denoting? A is the edge length of cube. In this case, L is equals to B is equals to H is equals to A. All the dimensions are equal. It is this one. Now let us go for the new kind of shape called cylinder. These are the things that we have to keep in mind. A student, do not forget this, because in the connected figure we have to connect these basic shapes. Come to the third one. Let us consider the cylinder. A student, cylinder is what? Two circular area. So I may draw this circular area means one coin is placed over another coin, means the same kind of coin. Take 1 rupees or 50 pice coin, you will get a cylinder. It is one way. Means placing one over the another, you are stacking it one over the another so that exactly means the other surface area. This is the bottom surface area and this is the top surface area. So one is just at the top or just opposite to each other, means one is just superimposing the other. It is one way. Another way is that this is the base of the cylinder you have taken. Rather than drawing it at the right angle, you may draw like this. A student, this is also cylinder. So this is our base surface area. This is the top surface area or surface area of the top. So first one is called as the right circular cylinder. And we have to learn about this one. It is the inclined or oblique cylinder. How we are observing oblique or inclined? For that, here we are observing that the curved surface area are not perpendicular to their base. Even more conveniently, we can observe if we allocate the radius of the base, and after this radius of this base, take the radius of the other surface area also, join it. In this case, you will get this central line or this axis. This is called as the axis of cylinder. So this axis of cylinder is perpendicular to their base. or perpendicular to their circular area. So it is this one. But in this case, if you are taking this as the radius and drawing the axis, this is not equal to 90 degree. So this is the thing. In our syllabus, we have to learn about the first one only. So we will not talk about the second one. Getting a student? So we will discuss for the first one. Always by defaultly it is given as a right circular cylinder. Just for your understanding, I had explained this. So we will confine to this one only. So in this circular cylinder, we have the R as the radius of circular area, H, the height of this cylinder is same as the height between the two centers of the circular area, or the height that we can consider from a point outside the cylinder to the other. But always we have to go the perpendicular way, need not go in the curved way, that will give you the wrong length. So H is called the height of cylinder. So in terms of the height and radius, we can express their curved surface area and total surface area. A student, for getting the total surface area, I need to consider the two circular area. They are like this one. These are the two circular area. If we are considering this two circular area, then it will give us the total surface area. If we are just leaving it and we are just considering this much, even a student, it will be hidden, the other one will be inside. So this yellow will give us the curved surface area. Since the surface is curved, we are using here the curved surface area, also called as the lateral surface area. So how to get this lateral surface area? How this area will be generated? If we just consider a thin ring, observe it carefully. If we are just considering a thin ring, if you have a ring or like your bangle, you might be using, some of you, not the all. Placing one bangle over the another, what you will get? You will get just a hollow cylinder. So you have to consider only that much part. So this boundary length of this base is obtained by considering 2 pi r. Now this 2 pi r is increased up to h time. So the curved surface area can be obtained by multiplying this boundary length of the base, not the area of base. If we are taking the area of base, then it will give the volume, because this will get filled, and the filled space always gives the volume. So this boundary length multiplied by this h can give us the curved surface area. So right here, curved surface area or lateral surface area is equals to boundary of circular area, means the circumference, right, like this. Boundary, it is important to understand, it will help you in remembering the formula if you are getting confused. Boundary of circular area. So this is the boundary length, student. It is not the area, but it is the like boundary length. So this boundary length is nothing but it is like our circumference. But this circumference have to be increased by their height. Means this boundary length is our 2 pi r. This is the circumference h. So CSA or LSA is obtained by multiplying your boundary length 2 pi r h. Okay, you can quickly recall it. Now what will be the TSA? In addition to this 2 pi r h, we have to add one for the bottom, one for the top. For this top, the area is calculated by pi r square because it is a circular boundary. Sorry, the circular end or surface of the cylinder. The another circular area of the cylinder is this pi r square. So we have to add pi r square plus pi r square means the 2 pi r square we shall add plus pi r square twice means twice of pi r h plus twice of pi r square. Common 2 pi can be taken or 2 pi r can be taken common. So it becomes h plus r. So it is our TSA. It is the formula for TSA. These formula are very simple. You have to just understand how we are calculating. No need to mug up. Now coming for the volume. Volume is very easy. For volume, the base area into height. The base area is the circular pi r square. This much area will just filled, means layer over the layer. This way the space get occupied. So pi r square h. So volume of cylinder pi r square h. This we need to keep in mind. Okay, student. These are the things that we have to keep in mind. Now let us go for the other one. Other one is our sphere. Then we will come back to the cone also. So a sphere, this is representation of circle. So how to differentiate it? For that we are putting another boundary here and another one here. The center is there. So here I can put this as R, as well as we can put on any of the boundary. Even we are putting here to here, this much is also representing R. This dotted line indicate it is projected inward and this solid line indicate it is projected outward. Okay, so everywhere, wherever you can take, it is always R. Okay? So this is the representation of a sphere. So for a sphere, this can be characterized by radius of a sphere. The ball that you are observing, that is of the spherical shape. In this case, there is no any specific area on which this sphere can be placed. Even if the sphere is placed over a surface, it is hardly resting over just few points. Okay, hardly 1 or 2 points are in contact with the plane. Therefore, in this case, top surface area and bottom surface area are not under consideration. Therefore, entire surface area itself is called as the lateral surface area or total surface area. So in this case, lateral surface area same as the curved surface area, same as the total surface area. And the formula obtained is 4 pi r square. How this is obtained, you will learn in higher standard with the help of integration. This can be calculated. And you will learn about this in class 12 with the help of integration. You will calculate. Right now, calculation is quite difficult. So in this case, we have to keep in mind whether we are saying the lateral surface area or curved surface area or total surface area, everything is always equal. It is this way. And volume is obtained by 4 by 3 pi r cube. A student, Pi is just a number. To identify whether r cube or r square, you shall keep in mind volume is a three-dimensional thing. So multiplication of three lengths are required. Here not separate length, width and height. So it is the r. So r must have the degree 3 for getting the volume. But for getting the area, it must have the degree 2. So power 2 is here. Okay. These are the things that we need to keep in mind. Now coming to the hemisphere. Student, write it quickly. The fifth one is our hemisphere. Hemisphere, or sometimes also called as the semi-sphere, that doesn't make any difference. Okay. So whether it is written as the hemisphere or semi-sphere, but the word semi is used commonly for the planar figure and hemi is used for the three-dimensional figure. So write hemisphere. How to draw? Means the sphere is cut equally into the two parts. While cutting equally into the two parts, each of this part represent the hemisphere. So it can be drawn like this. Means while cutting, this will give the circular area with the center, and this as the radius, and the other top one is there. So this one will remain as it is. This is also your r. Are we getting? This way we can represent, or even if you are representing like this, it's also okay. This is our r. This one is also our r. Okay. So in this case, we are observing that there is a flat area which can be used for resting this or placing this. So this flat area is considered as the bottom of this, and it is not counted in calculating the total surface area. So this is the bottom. Its surface area can be obtained by, since it is the circular with the same radius, because it is exactly divided into the two like diameter. So its area is pi r square. And how much is this curved one? The total surface area of the sphere means 4 pi r square is divided into the 2. So it is half of the 4 pi r square. Ultimately it is simply 2 pi r square. Therefore, in this case, I have two kind of thing. One is called as the lateral surface area or curved surface area. It is obtained by this one, 2 pi r square, and another one is the total surface area. This is obtained by adding this 2 pi r square, this one, with the bottom one or the top one if it is resting like this. Even this is also representing the same thing. So here it is our pi r square that need to be added here. So it becomes 3 pi r square. It is our TS. So questions are very easy, student. Just by adding this, we can get volume, half of the volume of full sphere, 4 by 3 pi r cube. So 2 getting cancelled. So volume obtained is 2 by 3 pi r cube. These are the things that we have to keep in mind. If we are forgetting, we cannot get the answer. It is this one. Now let us come back to the cone. Sixth figure is our cone. What is this cone? The safety cone that you are eating during the ice cream. It is the same cone which have one circular cross-sectional part. Another just above the center of this, you are observing there is a vertex. It is this one. A student, like the cylinder, it could be the right circular cone or maybe the oblique cone. Okay, like it may also be like this one. The cone is formed not just above the center of the circular area, but at somewhere else. So in this case, this angle is not equals to 90 degree, but in this case, this is our 90 degree. It is our right circular cone, and we have to stuck to only this right circular cone. So it is not a right circular cone, not a right circular cone. So these things we need not learn. Okay, you will learn in higher standard basically. If you are going with the mathematics in graduation and post graduation, then you will learn about this. For this cone, what are the parameters or the things by which this cone can be described? Very first we are getting it is the radius r. R is radius of circular surface. Another is the height. It is what? This height between the apex, or this is the tip or apex or even vertex of cone. It is this one. So the height between this vertex from the center of the circular area, it is called as the height of the cone. Height of the cone. So keep in mind, it is between vertex and center of the circular area. Okay, it is the second thing. Another thing defined here is this length. The length which is not perpendicular to this circular area but must be making some angle, and here we can observe that considering only one of the part means this vertical height, this radius, and on the same line moving downward, it is forming one triangle. So this triangle is means it is like this one means it is vertically and it is connecting like this. It is exactly like this. So this is when being rotated, this will remain fixed and this will move on the circular path, the other tip. So a cone is formed. So this length L is the length over the curved part. Here this length is different from h, and that can be obtained by applying the Pythagoras theorem. So this length is called as slant length, SLANT length. So it is along the surface. The students are many times getting confused. So keep in mind, there is a relation between R, H and L. It is forming a right triangle. Therefore, for this L, which is acting as the hypotenuse, and this height is perpendicular to this radius, hypotenuse L square is equals to the radius of the circular area square plus height of the cone h square, or L can be obtained by taking under root of r square plus h square. This is the other relation that we need to keep in mind. Do not forget this relation. Questions are also asked on this relation directly. It's enough. This is the new relation. Now coming to the curved surface area and total surface area. A student, in this case, there is one base. The base is this one. This is the circular. So this we need to be counted in the total surface area one. The remaining will give us the curved surface area or lateral surface area. This is obtained by taking the what here? Can we get directly from the H and R? No, because it is varying. You cannot write here as pi r square into H because it is varying. In this case, this curved surface area is obtained by multiplying this pi r with L. You have to keep in mind. Since it is the area, so 2 dimension, R have 1 dimension, 1 power, L have another dimension. So just keep in mind, the curved surface area is pi r L. It is our pi r L. This you keep in mind. For getting the TSA or the total surface area, how we can get the total surface area? In this, we need to add the bottom one, means pi r square. This area is our pi r square. This area just we have written, it is our pi r into L. So TSA is obtained by adding pi r L with pi r square. You may take the common factor outside, pi r as out, L plus R or R plus L. It is this. Get it? It is this. Now coming for the volume. A very interesting thing. The volume, do not worry for how it is derived and what is this. You just keep in mind the volume is 1/3 volume of the corresponding cylinder. If it were a cylinder with the same radius, same height, means the cylinder would be like this one, then whatever the volume of this cylinder, so 1/3 of this cylinder volume will give us the volume of that cone. It's so simple. So put the factor 1/3 here and formula for the cylinder, which was pi r square H. So keep in mind, in volume there is no L, but it is H, and obtained by placing 1/3 before the pi r square H. So it's so simple kind of thing. So this thing we have to keep in mind. So it means if we were making a cylinder with the same height, with the same radius, right circular cylinder, then it's 1/3 volume. Means if you take this cone, fill it with water, then you need the 3 times of the water present in one of the cone to fill a cylinder of the same height and same base radius. It is that. So only keep this much in your mind. It is enough. So it is regarding the cone. So this was all about. In our syllabus, this time frustum is removed, but still I am writing the formula for that because that is also very easy, but the chances of asking are very less because it is being deleted for this year. So the 7th one is our frustum. What is this frustum? Frustum is the part of a cone which is not including the vertical side or the vertex side, but the other side. Means what? If we consider a cone like this, And in place of connecting this, if we are just considering the intermediate part of this anywhere, what will be the intermediate part? It will also be the circular everywhere. So if we are not joining at one of the vertex, rather we are joining at their other circular area which have different radius than the radius of the base, but the center is just above. This is the location of center, means it is making right angle. It is called as a right circular frustum. If it is the tilted one, that will not be the right circular, that is beyond our scope. So in this case, we are observing the two kind of radius are defined. One is for this base, or the R1 we can denote this as the radius 1 for the bigger surface area, another as the R2 for the smaller surface area. Or many a time capital R is for the bigger and a small r for the small. The height h is also there. Is it okay? The salant length L is also there, but what is the difference? R1, or sometimes R is also denoted, or capital R is also used. So let me write capital R also. This is the radius of bigger circular area. Circular area of frustum, or circular surface of the frustum. Okay, of the frustum. R2 or a small r, it is the radius of other smaller circular area. Okay, it is this one. Another h is the height. It is always between two centers of circular area. And then L is there. This L is called as slant length. Now, if we observe carefully, here we are observing that slant length is not directly related with the H and this R1. But if we apply this Pythagoras theorem carefully, we can get it. Observe, how is this? A student, here we are observing that one surface is this, the other surface is the bigger one, and this one, it is like this one. It is our R2, it is like our R1. This is the length L. It is perpendicular, so we can understand this perpendicular maybe from here to here itself. This perpendicular length will also be your H, whatever the height. But in this case, while considering this H, now the new length will be this much. How much is this? R1 minus R2. R1 minus R2. So the triangle is now like this one. You may understand simply. You can remove this part. It is like this. So this is the new triangle. Therefore, L can be correlated with, means the L square is equals to, now this is the height H. So H we need to take their square, and the other part of this triangle will be our R1 minus R2. R1 minus R2. Their whole square need to be taken for applying the Pythagoras theorem. So this way the salant length is related. So the cone formula slightly get modified. It is this one. In the similar fashion, the lateral surface area total surface area for the cone, that formula gets slightly modified. So we shall remember in the term of the formula for cone with slight modification. A student, in this case, keep in mind the curved surface area or lateral surface area is obtained by, what was the earlier one? Earlier was our pi RL. It was this one. Here, just you have to keep in mind that this R, now we have the two kind of R. So this R shall be now replaced by R1 plus R2. So rather than pi RL, we shall write CSA or LSA as pi, keep it as it is, R1 plus R2 into L, or L may be kept before this. So pi L R1 plus R2 or pi R1 plus R2 into L. So this R of the cone have to be replaced by this one, we can get it. It's so simple. Many a time a student are getting confused. Very easy. Now coming to the TSA. How? So this curved surface area we have written. This top surface area will be how much? Pi R2 square, and this bottom surface area, very easy, pi R1 square. So it means this CSA pi L R1 plus R2 need to be added with pi R1 square plus pi R2 square. It's enough. Many a time a student try to recall. Nothing is there if you have the idea of the cone. Just slight one modification in the curved surface area. The same way the total surface area also get modified. So the only R have to be replaced by R1 plus R2, and the formula means the two surface area, they are of the different radius. So we have to keep R1 and R2 separately. You may write in the compact form, means taking the common factor. What is common? Only pi can be taken common. What left is L R1 plus R2 plus R1 square plus R2 square. Many a time students are getting confused with this in the volume. No, a student, here L R1 plus R2 is a two-dimensional kind of thing. Means the power of length and radius. One give the two-dimensional. Since it is the surface area, R1 square one take, R2 square you one take. Just add it. It's enough. So this way we can get. So even remembering this formula is very easy. It's all about. Now coming to the volume. The volume also get modified slightly with the radius only. What was the volume of a cylinder? So it was for cone. So the cone, from that cone applying 1/3 we are getting, for the cylinder applying 1/3 we are getting for the cone. But the radius, modifying the radius of the cone, we are able to get for the frustum. So volume of the cone is 1/3 of pi R square, and H was there. Now this R have to be, this is for the cone, this is have to be replaced. How to replace? Keep in mind, two dimension we have to keep. Two dimension means two radius R1 and R2. So a square need to be maintained. For that, you just keep R1 square, R2 square. It is the two dimension. But this square is not there. In addition to that, there is another factor R1, R2. So that the dimension, like the power of length is always 2 is maintained here. So this much replacement you have to do. Don't get confused of placing the 2 before R1, R2. No, otherwise it shall be written as R1 plus R2 whole square. That will give the wrong result. Therefore, the volume of frustum is obtained by just replacing this 1/3 of pi, and h I am writing just it before, and inside the bracket it become our R1 square plus R2 square plus R1 R2. It's enough. A student, many a time our students are getting confused this one with this TSA. But if you observe it carefully, results are very clear. In TSA, you need to take the L with R1, R2. There R1 square, R2 square. But in the volume, it need to be 3 dimension. So H is there. All the other terms should be in the 2 dimensions. Means there a square or the product of 2. Getting? So do not get confused with R1 square, R2 square in TSA. So here the confusing part is only this much. Say this much. Are we getting? This much is also matching with this much. But keep in mind, if you are talking for the volume, then you always start with this H. Taking this, forget for the L, you need to take R1, R2. But for the surface area, it is associated with the L. So L once taken, it must be R1 plus R2. With that factor, we need to multiply. This is the only difference that you have to keep in mind. It's enough. So this was all about the basic steps. We have discussed everything. Now, a student, for the other step, we can calculate very easily. I will just solve one of the question or give one of the idea. Then we will stop the class. So these are the basic structure, basic shapes that we have to keep in mind. Now, for the connected shapes or combination of shapes, or solids, how is this combination? I am going to take just one example just for your understanding. The first one, let me take a cylinder. This is the cylinder that I am taking. It is a regular right circular cylinder, though drawn horizontally. So don't worry for it. So radius is always the same. The height, this one is the height. Now at the end of this cylinder, there is a sphere. Means the sphere is connected at the end of this cylinder. It is that one. Means the sphere so surface area is common, the circular surface area. The radius is the same. We are maintaining the same radius, even we are writing from the same center to any of the point on this sphere. It is like this. We may connect on the other side also with a sphere or a cone itself. Let me connect with the sphere itself. In this case also, the radius will be like this one. The same radius is for this one. So how to get the total surface area and total volume? Just I will write the formula quickly. Rather than this one, at one end there may be one of the cone. This is the cylinder. This is hemisphere. This is other hemisphere. So for getting the area, you just write the area for each of this part. Area means for this, calculating the total surface area. Here we are interested to get the total surface area and the volume. These two things we want to know. The total surface area is obtained by adding the area of the cylinder. Which area? Only the curved surface area, student. Because the circular area are common. So that circular area need not be counted, rather the hemispherical. For the hemisphere, the curved surface area need to be counted. So here the area is 2 pi r, the ring have to multiply it with the h. And the area for this hemisphere is obtained by multiplying 2 pi r square. For this hemisphere also the area is 2 pi r square. Even adding these two, we will get the 4 pi r square. It is one thing. So total surface area, TSA. Student, again I am repeating, the circular area of the cylinder like this one, this is the common to the sphere or hemisphere also. So this area is not required. Rather, this area is replaced by the curved surface area of this hemisphere. Getting? So all these are only the curved surface area that we have taken. By adding all these three, we can get the total surface area. So it is like our 2 pi r h plus 2 pi r square plus 2 pi r square. Here, since we have considered the two end with the hemisphere, it is forming one of the sphere, RH plus 4 pi r square. Many a time in MCQs, just the final formula is written, which of this is representing the total surface area. So at that time, you have to do this smaller calculation and take the common factor like 2 pi r as outside, you will left with h plus 2 r. It is this. So it is the TS. Are we getting? So nothing new from the last day concept. So very simple. These are very simple things. Tomorrow we will learn about the transformation, means one shape converted into another, then the volume remains constant. That concept we will learn tomorrow, not today. So student, this way there could be any kind of thing. Even let me take one more shape. Frustum is not there, so we shall leave it. If it is like this one, we may take this cylinder. So for this cylinder, at one end we may connect one of the cone. A cone is there. And at the other end, maybe connected a hemisphere or maybe left as it is, or maybe one more cone there could be. Let me connect the hemisphere. It's very easy. The same radius r, the r is here. This may be the HC of the cone. This is our H of the cylinder. These things are required. So for the TSA, I need to consider for this cylinder. For this cylinder, their curved surface area. So their curved surface area I need to take. it is obtained by 2 pi RH. For this cone, again we need only their lateral, not the total. So their CSA for this cone, it is obtained by pi r L. L is important here. Question is that we are given with this radius and this HC. So this L first need to be calculated by applying this relation R square plus HC square. So first you have to do this calculation. Afterward, this L have to be substituted here. This is the additional calculation you have to do in case of the cone. And this is the circular and hemisphere. So this CSA of hemisphere is 2 pi r square. So this is obtained by add all these three parts together. 2 pi r square, 2 pi r h plus pi r l. Even only pi can be taken out and r is also there. So it is like our 2r plus the 2h is there plus pi is taken out and r is also taken out. So L is there. But keep in mind, this L is here, pi r 2r plus 2h plus sometime this value is substituted in the term of r and h. R square plus, at this time we have to take care, it is the height of the cone HC, their square. Okay, it's so simple. So please be careful. It is about this. So these are all about how to get the connected figure and their area. Now let me just solve a very small question so that you can gain the confidence that, see, everything I had explained. Okay, now how these are connected, everything I have explained. So when the body are connected, then how to get it? I will just solve one of these very simple question. Next day we will take more question. But before that, you have to try in your home. This is the question from the exercise 13.1. In such a question, you try to draw the figure first, recall the formula, connect it, you will get it. Two cubes, each volume 64 centimeter cube are joined end to end. Getting? So just you have to take the two cube. Initially, you may take this two cubes separately. For drawing the cube, keep in mind, draw the square. It is one of the cube. Two cube, each of volume means V1 is our 64 centimeter square. Even the same kind of other cube is also there, or exactly the same cube we may take together, or let me draw it separately first, then we will place it together. The second cube is also having the same volume. They are joined end to end. What do we mean by end to end? A student, it simply means these two are going to placed one after another. Say it is this one, and similar kind of another one is going to place here. Okay, I do not have similar kind of thing. Otherwise, if it could be the similar, then it could be like this. Okay, so by placing this, we will observe that some of the surface become common. Let me consider this point is going to merge with or going to match with this one. Then this point will match with this one. Okay, then this point will match with this one, and this point will match with this one. So drawing it together or draw it together, what we will get? Means this is ultimately going to give us, now the length become double. We are getting, this was the length A, this was also the A. This A can be calculated very easily by knowing this volume. So it is like this one. Now it is being, since it is being doubled, or we can draw like this. But these are the joint of the two cubes, so we shall keep that joint also in between these two. There is a joining of cube. You may complete it, or you can just understand with this much figure only. Remaining part are not required. Basically, for drawing the internal part is not required. This much itself is enough. Okay, it is this. So here we are getting that these two are placed such that this new cube is formed. Find the surface area of the resulting cuboid. What is the surface area? This surface area is asked, means it is basically the TSA. Unless or until it is asked, surface area default meaning is the TSA. Okay. For calculating the TSA, we need this length. This become, from the initial, the A and A, this become 2A. So the thing is that we need to calculate the A first. How to calculate the A? For this, the volume is given. So right, since V1 is equals to A cube, so this implies 64 is equals to A cube. So this implies A is cube root of 64. It is the cube root of 4 into 4 into 4, so that it can be taken out. So it is 4 centimeter. This implies side length or edge length is equals to 4 centimeter. This way we are observing that this much length is our 8 centimeter. This is our 4 centimeter. So this you have to just calculate the A from the given data. Then you have to depict in the other and quickly get it. Now TSA, for the other, how it is obtained? You may calculate the 6 surface area separately, or you may substitute in the formula also. A student, let me calculate it separately. So here we are getting one surface is this one. For this, I have this 2A length and the height is our A. But the same kind of surface is also behind this, what I have not drawn. What is the other surface which is hidden or exactly behind this? It is this surface, what I have not drawn. They also have the 2A length because it will fall on this one also. Are you getting? This way the two cube were earlier like this. Now it is okay. So therefore, this shall be multiplied with the 2 because of the hidden surface behind this front surface. So we shall put the another 2 before it. This 2A was because of this 2A. Okay, it is this one. Now again observe, the same is also true for this top one. If you are observing this one, this surface, the same A, but this one is again your 2A. So even we can multiply it by 2, or even same for the bottom one. So now again we need to take the A with the 2A and this need to be multiplied with the twice. Now what is left? The last surface which is left is only this one. The same identical one is this one at this corner, this surface. Are you getting? So that also need to be added, and they are 2 in number, means but their side length are A and A. So we need to put A and A, but this need to be twice. So just add it. So TSA become 2 to the 4 A square plus 4A square plus 2A square. It become 4 to the 8 to 10A square. So just substitute it here. So 10 into A is our 4 square. So it is 160 centimeter square. This is the answer. So the TSA is very easy. This was to be calculated. So student, we have to apply the formula accordingly. We need to calculate their side length or maybe the radius, like the formula for the cylinder, sphere. There the surface area or volume may be given and you need to calculate the radius. That can also be done. Then combining with the same radius you are framing the other, that can also be done. So it was like this. So the questions are very easy. Student, your time is up. So please try in your home. The 2 chapters are very easy and they are interconnected. We will solve more questions tomorrow and we will learn one of the small concept called transforming the shape. There the volume remains constant. Only one line concept is there. So do the exercise 13.1. It is related to cylinder only. Combination of solid. This even you can also do. 13.2. See this gulab jamun, how is this? Cylinder with 2 spherical ends. It's enough. Canvas, this, the cones are there. You please try with the 2 only. The other we will do later. Then their melting is there. It is at the end. Cone is also there. Yeah, in the same one there is some concept of melting. Exercise 13.1 and 13.2. Please do this much, students. Our next class again tomorrow we will keep, because already on Monday we have taken the break, so we cannot keep the break, and Saturday I may not be available here, so I may have to keep the break by default. So tomorrow we will conduct the class, so again at the same time, but what the time goes I cannot also say to you, but you should be ready since 8 o'clock. Yeah, student, any doubt then please ask. Yes, student, no doubt. Never you people are asking the doubt. It means either you people are too much brilliant. If you people are that much brilliant, then no need of tuition, or you people are even not understanding even a single thing. Only these 2 interference can be done. But anyhow, you please try and ask the question on next. Okay, student, any more doubt then you may please ask right now. And my advice is that for the last chapter, you people please ask your question or at least post your question in the WhatsApp. Okay, many a time a student are not able to solve, but they are not asking. Please ask your doubts. Do not get hesitated. Okay, students, so this was all about the today's class.